What's up, everybody? These are the 12 hardest algebra questions on the SAT, in my opinion. And they're not trick questions. These are types of questions that are likely to show up on most tests most of the time, such as no solution, infinitely many solutions, and word problems. I tutored this test. I scored a perfect 800 on it. You can watch me do that in the speedrun videos where I rip through the Blue Book test live. And these are the 12 that most of my students usually struggle with. Here's how to use this video. When a question comes up, pause it before I break it down and try it yourself. Then watch how I solve it and check if you did it the same way. Because on this test, the method is the difference between 40 seconds and 4 minutes on the same problem. Let's go. Okay, in the given system of equations, P is a constant. If the system has no solution, what is the value of P? We got to know this. This is our special case over here on the left, no solution. Means you got parallel lines, right? On a graph. So if we're looking at a graph, we want to make sure they're parallel. As equations, it means like they have to have the same slope. Different y-intercepts, but this question is never about y-intercepts, just about making the slopes the same. So you see, if I type this into Desmos, right? 7/4 y minus 1/2 x equals 1/3 minus 7/4 y, okay? It graphs that one, no problem, nothing missing there. The next one, if I do 1/4 x plus 5/3 equals py plus 11/3, right? Not gonna graph it yet because it doesn't know what p is, and that's the question, what's p? So one way you can solve this is just use the slider tool. You see, I click the slider, it makes the value of p be 1, and then I can move the slider and I can see like what's gonna make them parallel, right? So that's looking more parallel, maybe 1.5. It's not usually a decimal, so yeah, no, still not parallel. Let's try 2. What about 2? 2 also doesn't look parallel, so it's actually something between it, right? So it's like maybe 1.7 kind of, no, 1.75 then. This is the issue with the slider, right? Like if they put a decimal, so this one actually turned out to be a decimal. Most of the time it's a whole number, but this one's a decimal. If you have a decimal, it's gonna be harder to get the slider exactly on it, right? So let me show you the algebra. The algebra goes back to what I said. They just gotta be parallel, which means we gotta match their slopes. That's the annoying part here, right? You see these equations, they all have like fractions and stuff. So putting this in slope-intercept form is gonna be a little bit tedious, right? I'm gonna start with this one, it's a little easier. If I subtract 11/3 to both sides, 5/3 minus 11/3, that's -2, right? So I can write 1/4 x minus 2 equals py. And then I divide through by p, so it's gonna be 1/4p, and then it's gonna be 2/p, right? And so that's the equation, right? So that one's already, we can see the slope, it's 1/4p, right? Gonna get rid of that equation, we don't need it. This equation, yeah, a little bit more work. I'm gonna add the 7/4 over to this side and add the 1/2 x to the other side. So if I add 7/4 plus 7/4, that's 14/4 y equals 1/2 x plus 1/3. Now, I gotta divide by 14/4. So, you know, because this is Desmos, this is a great thing. You could just leave it like this, like you were dividing the 1/2 by that, that's fine. And also the 1/3. The 1/3 doesn't even matter because again, we're looking at our slopes. But now you see, I got my two equations in slope-intercept form, so it's this. 1/4p, that's the slope of that one, has to equal whatever this thing is. But that's the great thing about Desmos is we don't have to simplify it. Desmos will do it, right? 14/4. Now, if you want your answer, you got to make this x, and you see this green line pops up. We'll ignore this one. It's the graph of that one, and also the graph of that one. This is our answer. And if you zoom in on it, right, you can't click on it because x is in the bottom, but if you zoom in on it, right, 1.75, just like we have. If you do want to click on it, this is all you do. You see, you flip both fractions, right? So if you're aware of that, you know, then you can do it preemptively and, you know, then you can click on it, right? It just went, you know, for proportions, if x is in the denominator, Desmos doesn't let you click on it for whatever reason. But that's it. But that's a tough one. I mean, I think that's as tough as it gets with the fractions and everything. It just makes the algebra a little bit trickier. And also a good example of like the slider maybe not being ideal in that case, right? So great problem to understand. All right, next one. In the xy plane, the graph 3x plus 4y equals 1 and ax plus by equals 1 are perpendicular, right? So then it asks which of the following pairs of equations represents perpendicular lines. Basically, again, you know, if you've seen this question before, it makes a lot more sense the second or third time, which is why repetitive practice is like the key, right? You know, if you haven't seen this before, you're probably not going to get it right the first time, which is what this video explanation is for, you see. So these have to be perpendicular. So if I put this in, these two equations have to be perpendicular. So by knowing that, I can figure out A and B actually, right? And that's the whole key to the problem because these also include A and B and they have to be perpendicular as well. So perpendicular, remember what that means is just, slopes are opposite reciprocals, but to see slopes, they have to be in slope-intercept form, right? So I'm going to change both of these. So this first one, I would just subtract, right, 3x to both sides, and then I would divide by 4 on both sides, right? So it'd be negative 3/4, and then it would be 1/4, right? Then I do the same thing with this equation, right? It'd be by equals negative ax plus 1, and then I divide by b, right? So it's going to be negative a over b, and then 1 over b. So you see this slope over here and this slope, they have to be perpendicular. So what do I know? Well, I know if it's perpendicular, right, then, the slope has to be 4 over 3. So I got to figure out what this A and B have to be for it to be 4 over 3, right? So the way you can make that happen is you can say A is negative 4 and B is 3, right? And you see, once I've given Desmos the A and B, you can see they actually do look perpendicular, right? That's another good thing to know. Perpendicular lines, they just make a nice X or T shape, right? And that's exactly what we see here, right? Awesome. So I'm going to turn these graphs off because we don't need these graphs, right? But we want to keep the A and B because we want to determine which one of these answer choices are also going to be perpendicular. This is really easy. You know A and B, so now just type these into Desmos and look for the same perpendicular shape, right? So you see, if I put in answer choice A, those lines don't look perpendicular, right? If I put in B, right, what's that going to look like? AX minus 2BY. Those don't look perpendicular either. And then C has the same equation, but then it's 2AX plus BY equals 1. Still not perpendicular. Last one, AX plus 2BY equals 1. There we go. Those look perpendicular, right? So that's how you can do this one. Again, a tough question. If you haven't seen it before, that's going to be a tough one, right? But that's the thing, the SAT loves to repeat things, right? So you don't know it, not a problem, as long as you learn it and it makes sense and you remember it, right? All right, next one. Copper production in a certain region dropped from 5 million tons in 2004 to 2.7 million tons in 2017. Assuming that production decreased at a constant rate, which of the following linear functions best models the production in millions of tons t years after 2004? So once again, you're being asked to find an equation, right? So if you just read this, and this is why it's a hard problem, they don't give you points like outright. It doesn't seem like it, right? There are points, it just doesn't seem like it because it's just words, right? But if you got to come up with an equation, you have to have points, right? So since we have to have points, I'm going to add a table and I'm going to plug in 2 points and then I'm just going to see what the equation is, right? So there's one cheap thing that lets you at least narrow down to 50-50 right away, decrease, right? Decrease is telling us about our slope and the slope has to be negative. So it can only be B or C, right? So we'll get rid of, A and D in this case, right? And so, this is going to be between these two, right? So which one is it? Well, again, we need to have our X, we need to have our Y, right? And so we can kind of plug this in now, right? But we need to know what X and Y are, right? So it's over here. It says in the last sentence or last line here, F, which is the Y, best models the production in millions of tons, right? And then it tells us about T, which is our X. That's the years after 2004. So those are your points, right? X is years after 2004, and then Y is the tons, right? So when you go back and reread the first sentence, that's where you get 2 points. You see 5 million tons in 2004, that's a point. Y, the tons is 5 million. And X is years after 2004. So if it's 2004, that would be 0 years after 2004, which is why that's the y-intercept and why they all have +5, right? And here's the other one. It says 2.7 million tons in 2017. So 2017, that's going to be 13 years after 2004. So that's our X and then 2.7. Now we just hit our regression button and here's our equation, right? So we just got to see which one of B or C has the same slope. So you can try, B first, right? And we can see, does this number match this number? And it does, right? And so then we know it's B, right? And that's how we do that. Okay, next one. The table below shows the values of X and Y where S is a constant. Which equation could represent this situation? So you've probably seen a lot of these if you've already done some algebra, medium even. If you have a table, you can just put in Desmos and then you can do a regression and it generally gives you an equation. But you see, if I type these points in the table, Desmos doesn't like that. That's what these triangles mean, right? Errors. The reason it doesn't like it doesn't know what S is, right? In this case, you want to define a value for S, right? How do you know you should do that? Or you can do that, right? There's going to be other situations and other hard problems where you want to do exactly this, right? Here's the key, right? They tell you S is a constant. Here's my rule of thumb. As long as the question's not about that constant, it's not about S, you can plug in a constant for S, right? So I'm going to go with S equals 2, right? Don't use 0, don't use 1. Weird things happen with that. And also, if you kind of have like some constants that show up throughout, like 4 here, I probably wouldn't use 4 either because a weird thing could happen with that. So yeah, but generally just stay away from 0 and 1 and you'll be fine, right? So you see, once I tell it S is 2, the points show up and then I can even do a regression, right? The problem is, you see, now me matching this up with one of these is, you can do it because you can plug in S is 2 and just like do your algebra, solve them all for slope-intercept form, and one of these will match, right? The problem is that's probably not the best way to do it, right? Here's a better way to do it, right? What you should do in this case is, this is our equation, right? So what I can do is I can just enter in the answer choices and see if it's the same graph or not, right? So you see A does not match this graph. It doesn't go through those points. That's not it. So B, I try B then. Does that match? No. How about C? So let's go to C, Sx plus 4y equals 22. Nope. So what about D, 4x plus sy equals 22s. There it is, right? It's right on top of it, right? Turn that color off. There's the original one. And now you see I can change the value of S and this one's always going to work, right? So yeah, that's our answer. Not too bad. If you kind of know that you can tell it a value for S, that's not that bad. So yep. Okay, next one. The equation 7x plus 3 equals a times x plus d, where a and d are constants, has no solutions. Which of the following must be true? All right, so no solutions. That's one of our special cases, right? Here on the left side. On a graph, what does that mean? It means they got to be parallel lines. But we're not really looking at it as a graph. We're looking at it as equations, right? So as equations, this is what we want to know right here, the summary. As equations, this is an example. Same slope you see, different y-intercepts, right? That's what has to happen. So over here, you have 7x plus 3. And if you distribute a over here, it'd be ax plus ad. This is the slope. It has to match this slope, right? We said same slope. So you know a has to be 7. So 1 is true, right? So that's true. And then what about the other thing, right? The other thing is about d. And d is part over here, part of the y-intercept. And what do we say? We said that same slope, but different y-intercept. Usually they don't ask you about the y-intercept because it's literally that. The y-intercepts have to be different, right? So in other words, they literally just cannot equal each other. So it'd be like this, 3 cannot equal, right? I can't write it, does not equal sign here, but yeah, 3, let's see, let's do it this way. No, that's not gonna work. 3 does not equal AD. And so we know what A is, right? A is 7. So if you kind of get this, you divide by 7 on both sides and it's kind of like this, 3 over 7 cannot equal D, right? So that's my cannot equal sign since we can't do it in Desmos, right? So I hope that makes sense. That's the other option, right? You see D does not equal 3 over 7, right? So we want A, we want Roman numeral 1, we want Roman numeral 3, so it's 1 and 3 only in this case, right? 2 would be true if it said infinite solutions because they would have to equal each other, right? But for no solution, again, means same slope but different y-intercepts. So the y-intercept here cannot equal the y-intercept here, right? So hopefully that makes sense. All right, next one. For each real number r, which of the following points lies on the graph in the xy plane? So this one is hilarious to me because I've seen it before a few times, right? If you haven't seen it, probably you're not going to solve it the first time. Most people are just going to get stuck. It's a lot easier than it seems, right? You see, if you put these two in, what you see is they're the same exact line, right? That's what we see, same exact line, right? It literally tells us that one of these points lies on the graph. That means when I enter one of these points, we're going to see a dot on the graph, right? Because you can plot points. You see, I can plot like a point like that, but we're going to plot these answer choices. So the first one is r over 2 plus 9, comma, negative r over 2 plus 18. Okay, and now it's not going to draw anything because it doesn't know what r is. So you're going to say, I'm going to give it a value for r. And sometimes you need to do this for hard problems, right? How do I know I can do that here? It's because the question's not about r. That's the rule of thumb, right? So you can plug in numbers for constants if the question's not like what is R. And that should make sense, right? If the question's what is R, I can't just put in whatever I want. Got to figure it out. Don't use 0, don't use 1, right? So I'll typically use 2, right? So there's our point over here. By the way, anytime you write R equals a number, Desmos draws a graph, a circle graph with a radius of 2. So just turn that off so it's not distracting. But what we know, you see, is it's not A. So then I go ahead and enter B, 3R over 4 plus 9 over 4. That's also not it, right? So let's go to C then, right? R comma negative 4R over 3 plus 3, right? That's close, but still not it if we zoom in on it, right? It looks like it if you're not zoomed in, so be careful. So should be D. Let's confirm. Otherwise, it means we typed something in wrong. That's why you want to go through all of them. But no, there it is. It's on the line. And now you can see I can change this value of R, and the point's always going to be on the line, right? Pretty simple if you've seen it before. Otherwise, you might just mess it up, and it's really not that difficult. All right, next one. A bakery owner budgets $3,500 for supplies. The owner must purchase a minimum of 250 items to maintain its wholesale pricing. If the owner pays $650 per item for basic supplies and $18 per item for premium supplies, which of the following is the maximum number of supplies the owner can purchase within the budget and maintain the wholesale pricing? This should jump out to you that this is a system. You got two unknowns, right? Especially if you did the systems topic, which is before this typically. Basic is one thing, premium is another, right? Two unknowns, it's a system. So all of these things about money, right, have to go in one equation. So let's do this. Let's say 650x plus 18y has to be less than or equal to 3,500. Why less than or equal to? Where did they tell me that? It's the budget, right? Budget is the maximum amount, so you can't have more than that, right? So it's less than or equal to. The other equation is right here, the second sentence. The owner must purchase a minimum of 250 items. So that's the basic items and the premium items. So that's x plus y has to be a minimum, which means greater than, right? You have to, that's the least you can have, so it has to be more than that, 250 items. And so they want to know what is the maximum number of premium supplies, which we made y, that we can have, right? So that's like the highest point on the graph where they kind of overlap, which would be here, right? So this is the intersection point. So obviously you can't buy a fraction of an item, so I can't buy 163.04 items, right? So it's 163 really, right? And you can confirm this. 163 of this one and probably 87 of this one, right? And you can check that, right? So if 87 was the basic and, 163 was the premium, you see, when I do that combination, 87, 163, that's just under that budget. And also when you do 87 plus 163, you have at least the 250 items, right? So that's our answer. Again, the premium is what they want. All right, next one. In the given equation, S and R are constants. S is greater than 0. If the equation has infinitely many solutions, what's the value of S? So this is our special case of infinitely many solutions here on the right side. What does that mean? Well, on a graph, it means they have to be identical lines. What does it mean for their equations? Because we're looking at equations here. You see, it means their equations literally have to be identical. Same slope, same y-intercept, right? So what you can do here is the left side you can treat as its own equation. You see I can divide this by 5 to simplify it. It would become 3x plus 9 minus s over 11. That's the left side, minus s over 11. And the right side, I just distribute r. It's rx minus 4r, right? So what do we know? We said it again. Same slope, same y-intercept. The slope's the easy part. You see slope here is 3x, slope here is Rx, right? So R has to be 3, right? That's what we know. R is 3. I'm just going to write this here, but I'm going to replace, this. But you see, if I replace R with 3, it becomes this part of the equation. It was 3x minus 4R. It becomes 3x minus 12, right? So hopefully that makes sense. Now, you see the slopes match, 3x, 3x, but everything has to match, right? We said they got to be identical. Same slope, but also same y-intercept. So the y-intercept for this equation is 9 minus s over 11. That has to equal negative 12. So we write 9 minus s over 11 equals negative 12. And if you want Desmos to solve for it, it can. You just got to change your s to be x, right? And we zoom out, find the purple line. There it is. It's 231. That would be our answer for s. That's the final question. What is s, right? So again, just literally making them identical when it says infinitely many. We'll see this in other situations with like systems and everything. Okay, next one. In the given system of equations, g and k are constants. The system has infinitely many solutions. What's the value of g over k? All right, this is a genuinely kind of difficult problem. It's one of our special cases. Infinite solutions is this side over here, right? So in this side over here, they got to be identical, right? But you can't really do that in Desmos with a slider when there's two unknowns. It works, sliders work when there's only one unknown, not with two. Okay, so what does that mean? It just means they literally have to be the same. As equations, they literally have to be the same equation, right? So you want to figure out how you can make this equation the same as the other one. So one thing that would make that easier is if you just got rid of fractions. That's one thing here they're doing to make this more difficult. You see this first one, if I just multiply it by 8, it'll get rid of the fraction. So I'll get 6x plus 10y equals 3. So that's that equation. The bottom equation, I just multiply by 3. So it'd be like 3gx, right, plus 3ky equals 7, right? But they're still not the same. You see, it's like, here's my x and here's my y's. So I can't compare those because I don't know what k is, right? And I don't know what g is, right? So I can't compare those. What you can compare is the constants, 3 and 7, right? You want the whole equation to be the same. So we still got to change these to make these the same. So what do? Well, the least common multiple is 21. So you multiply this one by 7. You multiply this one by 3. So you get 42x plus 70y equals 21. On the bottom, you get 9gx plus 9ky equals 21. Now you see these are the same. Therefore, you see 42 has to equal 9g, right? And then over here, 70 has to equal 9k. So you see what's g? G is 42 over 9. And what's k? K is going to be 70 over 9. Finally, then, you see, what do we need to do? G divided by k. I told Desmos g is this, k is this. I can just ask it to do g divided by k. So we can enter 0.6 or 3/5, however you prefer to enter it. Both ways are accepted. All right, next one. In the given system of equations, w is a constant. In the xy plane, the graphs of these equations intersect at q, 13, where q is a constant. What is the value of w? Okay, this is an interesting one. So if you put this in Desmos, nothing's going to happen because, you know, Desmos doesn't know what w is, right? And it's in both equations, right? The key to this one is they're telling you where they intersect at. The point of intersection in the system is the solution, right? So if you know q, 13 is the solution, it means that this is the x and y value that would make the equations true, right? So what that means is I can replace x with q and y with 13, right? So if I do that, it'd look like this. It'd be negative q and then w times 13. And then down here, it'd be 2q minus w times 13 as well, right? Now you have a system and it just has q and w, right? This is good though, right? A system should just have two unknowns. Now we have two unknowns. Before we had x, w, y, right? We couldn't do anything with it. Now you have two unknowns. You could have Desmos solve this. The thing is, Desmos will only solve it if it's x and y. So I'm going to say x is q, right? This is just for my own reference, and w is y, right? So I'm going to replace this with x, the q's, and I'm going to replace this with y, right? And then you see Desmos has no issue with it. We can find the solution. My x is my q, right? They wanted what's the value of w, which is the y, so that's 7, right? So hopefully that makes sense. Okay, next one. In the given system of equations, p is a constant. If this system has no solution, what is the value of p? Okay, really common problem. No solution, we got to know their parallel lines. What that means is they have the same slope. The curveball that they throw here to make it even more difficult is they don't use the variables x and y, right? They use r, p, and w, right? So you have to know which ones are the variables, right? That's why they'll tell you this usually, what a constant is. A constant, when they mention that, it means it's just a number. You have constants and you have variables, right? So like 15 is a constant, it's just a number, right? So they're telling you p is a number, it's not the variable. So that means r and w are your variables, right? So you see, if I enter this in this way, Desmos won't like it. But what I should do in this case is I'm going to change like r to be x and w to be y. And then same thing on the bottom equation, 3x minus 4y equals 8y plus 15. Now, these have to have no solution, right? So one way you could do it, and it's usually like a fast way, is if you use the slider, you see, you'll set the value to p to be 1. You could just slide it until they look parallel, right? So not quite, but they were getting there, right? So I just need a bigger number than 10. So you click on these ends and you can adjust these like values. So let's go 0 to 20. And I'm going to use a step of 1, right? A step of 1, every time I move, it's going to increase by 1. Usually this answers a integer, and there it is, right? It's 12. So if I go out, 100 units each way, it remains parallel. I can be certain it's 12. But here's the other way you do it. Remember, no solution just means they have to have the same slope. Just solve each equation for y equals, so it's in a slope-intercept form, and then you can find their slope. So like this first one, I just divide by p throughout, so it'd be like 9 over p plus 3 over px. And this other one, a little bit more work. I'd add 4y to this side, subtract 15, so it'd be like 3x minus 15 equals 12y. And then I divide by 12, so it's 3 over 12x minus 15 over 12 equals y, right? These are my two equations. This is the slope of one, 3 over p. This is the slope of the other. So you see it's like 3 over p has to equal 3 over 12. Well, yeah, that's why p is 12, right? So you can also solve it this way. The benefit of this is, you always get an answer. So even if it was a weird number and it wasn't an integer, you could figure it out this way. Whereas like if this was a weird decimal, you wouldn't get your slider perfectly on it, right? All right, next one. For groups of 20 people or more, a zoo charges $18 per person for the first 20 people and $12 for each additional person. Which equation gives the total charge in dollars? That's the y, the f, for n people, right? N is going to be like our x here. So you got to pick out the correct equation. The safest way to do this is always just to add a table and give Desmos 2 points, right? A lot of people are going to pick the wrong problem here. They're probably going to pick A, I think is the trap answer. Most people will fall for it, right? But I'll show you how to avoid that. The way you avoid that is just you come up with 2 points, right? X is n in this case, which is the number of people. And then the y is the amount of money, right? And the thing you got to know for this only works for more than 20 people, right? So if I want to plug something in for X, it's got to be 20 or more. So I'll use 20. And I calculate that. It says $18 per person for the first 20 people. You do that, that's mental math even, it's 360. And what about my second point? Well, then it says it's $12 for each additional person. So that simply means if I had one more person, if I had 21 people, it'd be $12 more. It would be 372. Hit my regression button. Here's my equation. Then I know it's B and I don't fall for the trap, right? So if some of those felt rough, here's the thing. Every one of those questions is live on Sigma Prep with fresh variations. So you can drill them until they are automatic. This is the practice section, the algebra ones. This is exactly where this video came from. And there's plenty in here that didn't make the video. I picked the ones you're most likely to see on test date. From there, you can go and take a free practice test. It's full length, real scoring. When you finish, you'll see exactly what you got wrong. And there's my video explanation on every single one, even the ones you got right. So that way you can check whether your way was the most optimal way or if somehow I did it in a more efficient, faster way. So you get feedback in both directions. And here's the newest thing here on Sigma Prep. Once you complete this test, it will build you a study plan based on your results. Take a look at this. It places every topic based on what you actually missed and orders in a way I'd order it for a student of mine. The heaviest stuff comes first because that's what's going to have the most impact on your score. And as you clear the sections, it unlocks checkpoint tests. And if you say your test date, it will tell you how many practice sets and sections you want to complete per week to keep you on pace to make sure you've covered all the ground before your test date. I thought this was great. You don't want to be practicing, and wandering around without some kind of direction. So this will give you the guidance. It'll map it out for you, your whole test prep. So take advantage of this. Let me know what you think of it. There are also 24 full-length practice tests on here. Everyone mirrors an official Blue Book test, right? They're all based on, the actual test. There are 3 variations of each. So a retake is never just a memory check. You actually have to know your stuff because each one is going to be different. The answers are never the same. All of this is free to start. No payment required to sign up. The first full test is on me, link below. Go get your points and subscribe, like and subscribe, and I'll see you in the next video. That should be the advanced math one. It's gonna do the same thing, the hardest one's there. That should be coming out pretty shortly. So yeah, like and subscribe, follow for more, and keep studying. Take care.